Hello, welcome to the next video in our geometry unit. Sorry. Today we're going to talk about angles, which is section 10.2 in your textbook on openstax.org. So let's define what an angle is. An angle is a joining of two rays which sweep out as the sides of an angle with a common endpoint. So what we mean by that, there we go. So here are my two rays, QR and QS. Notice that they both originate from the same point of Q, and they're not opposite rays. They are, we consider, I guess, conjoining rays, but they both two rays that share a common endpoint, and then the angle is in between them. So we could say that this angle right here is the angle that's formed from ray QR and QS. That common endpoint has this name. It is called the vertex. Writing on here is much worse. So this is the vertex. Now, yes, it has the same name as the vertex of a parabola, but we're specifically talking about an endpoint in this case. All the vertices and vertices that you're going to see in our unit of geometry will be a point, and it will be at a corner rather than a curve like we saw in the parabola. The vertex of a singular angle can be seen as the center of the angle. That is the midpoint or the center of the angle. Let's look at the notation for angles. So notice how this angle looks like kind of like a side V. When we talk about angle notation, we're actually going to use that side V. This symbol right here represents an angle. I can call this angle 1, or I could call this angle SQR, where S is on one ray, Q is the endpoint they share in common, and R is the other ray. I could also state that this is angle RQS as well. So long as the vertex is in the center, I can use either direction for when it comes to naming the angle. Angles are measured in either degrees or radians. For this course, we're going to stick with doing degrees, which is denoted by a tiny little circle in the upper side of the numbers. For our class, we're going to talk about the degree of angles will either be between 0 and 360. We won't go beyond that, however, a sum might go beyond 360. Some angles are referred to by its measure. Here are a few of them. A straight angle, as we see here, has a degree measurement of exactly 180 degrees. So if you have an angle that is measured to be 180 degrees, then it is a straight angle by definition. A right angle is half that. It is exactly 90 degrees. So a right angle is defined by the fact that it has 90 degrees, and that is the definition. Straight angle, 180. Now an acute and obtuse angle, there we go. An acute and obtuse angle are not necessarily done by a degree, but it's in a range of degrees. So an acute angle must be between 0 and 90, where those 90 is not included, while obtuse must be greater than 90 and less than 180. You'll also see that we talk about a reflex angle and a full angle. The reflex angle is simply the opposite side of an angle. Normally we only measure angles between 0 and 180, and anything beyond that is considered the reflex angle. However, we're going to mostly focus on angles that are within in between the two rays that make up the angle. Now let's talk about some special angles. The first one is going to be the adjacent angle. Now adjacent angles are angles that share a common ray and a common vertex. So here's my common vertex. Notice that this side, this ray BD, is considered the common side because I have the two angles angle ABD and angle DBC are considered the two adjacent angles. I could also note this as angle 1 and angle 2. This is how I would name those two angles, and they're adjacent because they share that common side, namely, or I should say common side, which is the common ray of BD. The next we're going to talk about is supplementary and complementary angles. A supplementary angle, or supplementary angles, are a pair of angles in which their sum is 180 degrees. Now these angles could be adjacent or not adjacent. As long as their sum, as long as the angle measurements add up to 180 degrees, they are considered supplementary. With complementary angles, it's the same idea, but instead of not 180, it's 90 degrees. They could be either adjacent or not adjacent, but as long as their angle measurements add up to the desired sum, it is considered either supplementary or complementary. So let's do a quick example. If I suppose had the angle measurement, let's say I have an angle measurement, so this is going to say measurement of angle, let's say 1 was equal to 36 degrees, then its supplement would be equal to 180 degrees minus 36 degrees. So let's see, that's 180. So let's see, that'd be a 4. Then we have 7 minus 4, so 144. So we would say that 36 degrees and 144 degrees are supplementary of each other. If we have the same measurement of the angle, the measure of angle 2, or measure angle 1, sorry, let's keep that consistent, we'll do 36. But now if we want to do the complement of that angle, this is the same thing as 90 minus 36 degrees. We still would have the 4. Then we'd have 8 minus 3, which is 5. So the complement of an angle measuring 36 degrees would be 54 degrees. Please note that for both of these, there is only a pair of angles, so an angle can be supplement to many other angles, but it is only the one measurement. Vertical angles are two angles that share a common vertex and are made of opposite rays. So if we were to label this on the diagram, if we were to label this, let's say as, it doesn't want to work for me. Let's highlight it. Come on. Let's highlight there. Ooh, not black. Let's do black. So if we were to go right here and say that was, A, and if we were to have this as B and C and D and E, for example, then we can see that we have opposite rays. We have ray of A, AB, and we have the ray AD. These are considered opposite rays. And then we also have AE as an opposite ray, and we also have AC as an opposite ray. And all of them go through the vertex of A. So we would say that angles 3 and 4 are considered vertical angles, and we would also consider 1 and 2 being vertical angles. Notice that they are on the opposite side, or if they were directly across from each other. I got more text to come up. So if we were to have vertical angles, here's a question to think about. What do you think the relationship of the measures of the vertical angles are? This is one of the questions we're going to answer in class. So let's talk about a transversal. There are a bunch of other relationships with angles, but we have to talk about a transversal first. A transversal is a line that simply passes through or cuts two parallel or two or more parallel lines that are transversal. Notice here in the diagram that we have two lines, M and N. We are going to assume that they are parallel. When we talk about shapes, we'll talk about symbols that will state parallel. Here, this line T is a transversal. It is a line that is dividing into two parallel lines. You'll notice that it creates a set of 8 angles. 1, 2, 3, 4, 5, 6, 7, 8. When we do this with parallel lines, we get different relationships and the same relationships between different angles. We will look at properties of these angles in class, but today in the video, we're just going to talk about the definition of them. So again, the line T is a transversal, and the lines M and M are considered parallel lines. So let's talk about one of the first types of angles that are made with a transversal. Here we're going to have alternate interior angles. These are angles created by the intersection of the transversal and parallel lines that lie between the parallel lines. So what I'm referring to are the angles 3, 4, and 5, 6. Please note that alternate means opposite side. Interior means between the lines. In other words, between the parallel lines. So in this diagram, angles 3 and 6 are considered alternate interior angles, namely 3 and 6. Also, 4 and 5 are also considered alternate interior angles. Note that they are on opposite sides of the transversal and in between the parallel lines. So alternate means they're on opposite sides of the transversal. Interior means they're in between the parallel lines. What do you think the relationship of the measures of the alternate interior angles are? Again, this is a question we will ask and answer in class. The next is going to be the alternate exterior angles. Alternate exterior angles are going to be the angles that are created by the intersection of a transversal and two parallel lines that are outside the parallel lines. Here we have angle 1 and angle 8. Notice that they are on opposite sides of the transversal, but they are outside the parallel lines. Alternate, opposite sides of the transversal, exterior on the outside of the parallel lines. That also means that 7 and 2 are also alternate exterior angles. What do you think the relationship of the measures of the alternate exterior angles are? Again, a question we will ask and answer in class. Corresponding angles is another type of angles that come when we take two parallel lines and cut them by a transversal. Corresponding angles are angles created by the intersection of a transversal and parallel lines that have the same position on the parallel lines. So an example of that would be angle 1 and angle 5. They are both on the, in this case, the left side of the transversal and above their respective parallel lines. We also could say that 8 and 4 are considered corresponding. They are both on the right side of the transversal and below their respective parallel lines. What other pairs of angles that are corresponding? Take a moment to think about it. We'll also answer the question in class, what do you think the relationship of the measures of the corresponding angles are? Linear pairs. A linear pair is two angles created by the intersection of by transversal and parallel lines that are adjacent and combine to make a line. Here we have angles 1 and 2. So 1 and 2 combine together to make a line. We also can say that the angle measurement of linear pairs is 180 degrees. Doesn't that sound familiar? Essentially, a linear pair is a pair of supplementary angles, but they specifically make up a line in the transversal, or in this diagram. But we also know that these two, they lie on the transversal, and therefore 2 and 4 are also considered a linear pair. There are many other linear pairs in this diagram. Take a moment to see if you can figure out some more. We'll also talk about other relationships between the linear pairs. There might be something to say of the fact that 1 and 2 are a linear pair, and so are 2 and 4. This ends the video today. We will talk about the measurements of these angles and work with these angles in class. If you have any other questions, please read the section chapter of 10.2, which talks more about these angles.